There is a bug, indeed. Okay, take 3. So I'm sharing this roadmap sketch. I was saying to Sunjay earlier, I think what I would love to do is we have this sort of long list here of stuff. I would like to kind of break it down into things sort of a rough triage at the ideal level of what we think we want to focus on. And I think we might see some grouping arise and then look a little more detail at some of the individual items. Like I guess one thing that's worth, even before we even start, like when I say defining who we is a little unclear to me. So I think there might be a couple of groups of people. There's obviously some, let's see, who is we? There's obviously like compiler lang split, which is sort of like semi-artificial, but there's what I mean by who is we is I could imagine the traits group breaking into some kind of smaller groups that are more focused on individual tasks a little bit, and I don't quite know what those groups should be, but I think that will be possibly a useful thing to do. So I think what I would probably prefer, that said, is, well, one of the questions we should think about is like, what kind of lang design questions do we think we should prioritize now? Like, I think we'll see at least a few categories. Like specialization has kind of interesting questions around the chalkification, and then some around the like extensions to intersection nibbles or whatever. And that's kind of a nitty-gritty thing. And then there's stuff like syntax, where there's literally syntax questions like on the far extreme, and design of that level, like user-facing in a very direct way. Does that sound like an accurate assessment of the situation? Okay. The other thing I was telling Sunjay is that I've decided to give in and just adopt Dropbox Paper as my tool of choice, meaning in addition that maybe we'll try to get people into the like Rust group, the like Rust Dropbox team, so that we can actually assign people things and use that. It's kind of a nice, just sort of like for the team planning level. There will be GitHub issues where appropriate, but I don't want to go like create a whole bunch of GitHub issues for like prospective work we plan to do, or stuff like make a plan. So, okay. So all that said, part of why I'm saying that is I find this document already sort of unmanageably big, and I'm thinking I made a folder, but I didn't move it in there yet. Let me do that now. Oh, I didn't even make a folder. Let's do that. I was thinking of breaking some of it into separate documents, like for different ideas, but possibly not live at this moment. But so there's like this list of stuff, right? And some of it is reflected up here and some of it is not. So maybe the thing to do, let's first just go through them and look for like short-term ones, I guess. So associated traits and quantification over traits, what even is this? This is, okay, this is like far future. It seems pretty clear. I'm gonna tag it with.
I'm trying to get Central in. He should be here in a second.
Oh, great. Okay.
And I think this is something he's particularly interested in. I agree that it's far future, but it may be, well, Central can say more, but I think like
all right,
well, to be thinking about it,
Okay, I don't know if I agree, but that's okay. We can have that conversation. I understand why you might want to. Yeah, maybe it's good. So let's categorize it like this. Kind of work required. I'll try to make some buckets. How can I paste this without stuff? actually don't know. There's different. I'm going to leave it for now because I actually don't really know what kind of work we foresee. I see some different versions. Oh, hey, Central, you're here.
Hey.
We're trying to kind of go down this list and break down what kind of work we think there is for each of them, so we can sort of put them into buckets of like which ones are worth really elaborating in great detail. And I was trying to push back on the idea of pursuing associated traits and quantification over traits in the short term, but Aaron was telling me that you might think that you might be wanting to do that. So I'm curious.
Short term? No.
I don't know. That's good.
That doesn't seem realistic.
Okay, maybe in
at least from an implementation perspective, because we don't even have an RC.
What kind of work? Like, it seems to me like there's a couple kinds of work here. I wrote down in this paper doc, like describing the semantics. Basically, I think there would be work just experimenting, ignoring kind of the syntax to a large extent and saying, here's how it would look at the logical level. There's obviously some work sketching out the syntax.
That seems obvious.
Seems like that's about it. I don't know. That's kind of exploratory work.
Well, there might be. So if you use an associated trait or some quantified traits with trait objects, then you might get into trouble. Like, do we know that the trait do we know that the quantified trait is object safe?
Okay. So it's basically exploring and finding the interesting questions. Okay, that seems like.
I think I linked my repository.
Yeah, I know. I don't want to I'm trying to like condense down from too many details. Like, there's a more detailed version up there, but where clause on enum variance. So this is basically GADT, AKA, right?
Subset. No extension quantification and no type equality constraints.
Seems like this again is sort of the same nature of work as I would call these both like exploratory semantic work.
Right.
And that's kind of
it seems like gadgets or enum variants interact with NLL in some way, perhaps.
Okay.
And at the very least, pattern matching, because you need to get out the witness that you need to extend the context with a witness that the type parameter satisfies the constraints.
Yep. I don't know how to structure this in paper, but that's okay. That seems fine. I'm just going to write it like this. I'm hoping we can kind of group these into like the kind of work that is needed, and that will give us some idea of where it fits in our overall plan.
Yeah. Someone already made an internal thread for the enum variant stuff out of the blue, I think.
Yeah. So as ref limitations, this is probably a similar general nature of the work. I would say we want to like research some use cases, blah, blah, blah. I guess that's another thing that could be here. Named existential types. What is this? This is being able to write type foo equals impl bar, or
yeah.
Okay.
Yeah, I'm writing an NFCP right now for that one.
So is this literally just
the syntax? Yes.
Okay. There is probably some other. I think there's more work in this area than the syntax.
Yeah, probably.
in particular, there's like the syntax RFC, yes, but the current implementation, if I recall, has some deviations from sort of the RFC. I feel like it would be good to go over the semantics in detail of what we expect.
There were some recent changes that Oliver merged, which may have addressed problems. We should probably talk to Taylor and Oliver.
I think this might be a kind of work that is somehow shared with like specialization to a certain extent, of like specifying and ensuring that implementation kind of does what we want. We'll see, but
right.
Let's go back to the next thing on the list then.
Once we merge the syntax RFC, we will also need to change the implementation, and that will take some time. Not too much time, but
yeah, that's the easy part, basically, in short.
Right.
Or, yeah, maybe, depending, I guess.
Ish.
Right. It depends, I guess, on how well that, like how much that syntax allows things that the existing syntax doesn't. But
so in the FCP, I propose that we lift the restriction around where you can put it, so you can like have a tuple of input bar and class.
That's kind of what I was referring to. But yeah, okay.
That should be mostly a straight like recursive desuring.
So there's the matter of using impl-trait in let bindings, which is like half implemented, but we need to kind of redo that. I feel like this is mostly implementation work, I think, at this stage.
Right.
And so what's needed is to like draw up implementation roadmap and
so this is also for constant statics. And presumably we should also make this work for type description, but type description is not stable, so.
Right, okay. So I don't know to what extent I'm just going to call it impl-trait and bindings to cover those more general cases.
Yeah. I would, yeah, that makes sense.
Why is this cursor not where I expect it? What's going on? Stop. Okay.
So I was skimming the conversation you had with Alex, Greg, and I was thinking that it would be good to not split people up into too many different things. Like if Alex is working on this, it should be finished, so that we don't have 100 different things that are like semi-finished.
As the goal of this meeting is to identify, in my mind anyway, or it's probably not going to happen all in this meeting, but my hope is, yeah, exactly that. I totally agree. Is basically to try to group these things and then figure out 1 or 2 or 3 that we're going to do. The challenge might be that if we're like there will come a time probably when there's like things that keep everybody busy requires some splitting, and I don't know, maybe the answer is everyone will just not be busy and we'll find other things to do. Like it kind of, I think it's kind of gated by how much I want to call it leadership bandwidth or something, but I don't know, gated by different kinds of bandwidth.
Sorry to interject. Yeah, just to clarify things on my side, I'll probably finish off associated type bounds, which is Central's ROC, because that implementation is largely, well, it's about 2/3 complete. I also wanted to help get the existential lifetimes implementation, hidden invariant lifetimes in existential types over the line. And then only after then would I probably consider working on the infiltrating binding stuff. So yeah, just so you know my roadmap. So I'm not really planning to split time. That's definitely sort of a midterm
So
goal.
once I've completed this FCP, I will start working on the tests. Oh, yeah.
Yeah. Okay. Yeah, that would be nice. Yeah.
Maybe when I'm done, you will feel differently about being 2/3 done. But
yeah. Possibly. Well, unless I've magically, implemented every corner case correctly, which is probably not the case. But yeah, there's no huge rush for that. But anytime in the next by the end of this week would be lovely. But we'll see.
So let's see. By the way, did you all see that notification that just popped up for me? I'm hoping not, but.
No, I didn't. If it was private, rest assured, I didn't see anything.
It wasn't, but I would, if in case any future ones show up that I don't want to be seen. Hoping I have it set up right. Okay. Existential lifetimes in infiltrate. So, right. So, okay. So I have these two things. I don't really know quite how to categorize them. So the first one would be, I think, let's go back 1 second. Trait object upcasting. So my sense is this is something that it's a kind of implementation task, but there's definitely some amount of design of like, we have to propose a vtable layout and, well, maybe we do, maybe we don't actually. For trait object upcasting, maybe not.
Is that really a VG traits thing though? The representation thing seems like.
I think it's traits, yes. I mean, how is it not?
Sure, some parts, obviously.
I mean, what other working group is it if it's not traits? Let's put it that way.
Yeah, well, this sort of upcasting is there. I'm confused as well.
Like, it feels like it might as well be. I don't know. It doesn't.
Yeah, sure. Why not?
So, I mean, I know what you're saying. It's a little different than like chalk lowerings and so on. Yeah. But that's okay.
But I assume you're familiar with those parts of the compiler as well. So.
I think the trait object upcasting in particular can be grouped together with infiltrate and bindings and existential lifetimes and infiltrate, in that they kind of fall in the category of like, it's not exactly clear what code we should write, but it's not like major language design that is needed. It's more like working through and figuring out the code. They're different in their difficulty level, but that's okay.
Sorry, Nico. Have we decided what sort of level of design we need for upcasting and, well, potentially multi-trait objects, like an ERFC, a full RFC, or just experimentation?
So I don't know about that. I am distinguishing the upcasting from multi-trait objects, definitely.
Yeah, sure. I mean, they kind of go hand in hand, I think you see, but upcasting can definitely be done first, I think.
Are there any lang design questions around upcasting?
I think we'd have to figure that out as we went. Like, I suspect the answer is there are some, but not major ones.
So you'd be more in favor of just, diving into having some discussions, diving into implementation and experimenting, and only if serious ones come up, potentially going the RFC route?
I mean, the way I would see it is, if we decide to do it, we're going to pick a few of these things, right? And it's kind of in an early stage. I don't think there's anyone who would seriously propose that they should not be upcastable. So it's really a question of like how to do it and what the ramifications are. And so
I tend to agree, yes.
So the work would be like spelling that, exploring that, and then kind of writing up our conclusions. And if that's kind of moving in terms of, if you think of it like the stages, we're sort of in the design stage and implementation, right? And at some point we could float it. It might be that it's all very straightforward and we say, hey, this is it. Or it might be that we discovered, oh, there's a complicating factor. We should bring this to the Lang team. And
is it worth having a meeting over that, like I was suggesting, just before someone dives into the implementation?
Yeah, the way I would probably say we would
get involved.
That's what I would think, that the starting point for one of these would be an initial meeting to like brainstorm out the details and so on, and figure out from there what we think we need to go next.
Yeah, let's do that.
That sounds good.
Okay, associated type bounds. This is the thing where you can sort of have an anonymous. Yeah. Anyway, the like.
I'm going to get back to very soon, hopefully.
So that, where does that fall under? I guess that's implementation work.
Yep.
Oh yeah, the RFCs.
This is a little different than these other ones in that, well, it's similar to infiltrate and bindings, but there's kind of like, it seems like there's a little less design. It's a little more known.
Yeah, well, the RFC is
maybe not.
I think that was Central's RFC. Obviously, it's just the one you're writing tests for. But it's reasonably clear what I need to do. The only thing we had was the discussion around defining uses, possibly existing in terms of associated type bindings.
Right.
And whether there are a few concerns expressed about that. It's sort of ballooning into a full-blown solver, or you would require some sort of full-blown solver to actually find defining uses in complex cases. But we think we can just do a simple case.
Okay.
Yeah, I think. Do you remember this discussion? I think Ollie was involved briefly, and
I remember it. Yeah. So, okay.
But that's like the only slight, language design. I mean, if you even call it that, issue. And we kind of came to a conclusion that we can just experiment on this. Although I haven't really started work on it yet. I think I know what needs to be done.
I have no idea what you're talking about. With
yeah, sorry. It's probably easiest to see the. I think I have a work in progress PR open, and there's a bit of discussion towards the end. So have a look and let me know if you have any questions.
Okay, I will.
I think that, it's okay. I think so I put a few more things in here. I think they all are sort of falling in this category of like, we kind of know what to do. We have to talk about
I think some of those are more distinctly midterm things than others, and some much more short term, but I agree they're all roughly in the same category.
I'm going to go ahead and throw the type alias bugs thing in that category too.
Is that like bounds not being respected?
That's exactly what it is.
Okay.
It's not exactly clear what I'm not convinced it's all bugs, but yeah. Making a better story.
Sorry, I saw a note about trait aliases. Open questions about trait aliases still. I wasn't aware there were any open questions around trait aliases.
Central.
As in not associated trait aliases or anything like that, which I saw floated as an idea.
Well, Central has concerns. To be honest, I don't exactly remember what they are, but I don't know that we want to go into them right now. But
okay, that's fine. That's fine. All right.
But yeah, so for implied
around what?
What's that? Oh, about trait aliases.
Oh yeah. No, we're definitely not stabilizing those until we have associated traits.
Or at least until we've worked out enough to feel confident, I guess. So GATs, yeah, okay. So this is good. We're getting close. I think we can then refine these categories a little bit. But I put implied bounds under the specifying work because it's not exactly the same as named existential types, but it feels similar in that I feel like we kind of want to, it's mostly about making sure the implementation in terms of what, it depends on Chalk, but it's relatively straightforward after that. But it's mostly about making sure that we know it's doing what we want it to be doing and we're happy with that. Generic associated types, I think, fall under this. They're mostly a matter of implementation work. Specialization, that's an interesting case. It kind of crosses a lot of boundaries. I guess I would put it under specifying work for the most part, though. And Chalk integration, that's a kind of category of its own. But there's actually a couple variants of this that I think are interesting, right? So there's integrating into Rust-C, at least. There's integrating into Rust Analyzer, which might be a different way to go about it. And then there's, maybe that's it. There might be some amount of cleanup on Chalk itself. I don't know if that counts. So looking at these items, part of why I'm trying to, especially the implementation ones might be something we want to reshuffle. But part of why I was trying to budget it like this is to say that I imagine we might be wanting to do, like, these require different sort of human resources, these different categories. And I feel like we probably want not too, the specifying work in particular, I think, feels like we want people to be doing only one of those things at a time is my guess, so that we have enough like time and energy to sit and think about their implications. This feels mildly more parallelizable if we have enough people, but it's more a matter of hacking. And then, does that sound plausible? Maybe we can. So within these, I would say there's like probably stuff that can be done in Rust-C today relatively easily, which I would include. I believe that's true for GATs. I believe that's probably true for trait object upcasting, infiltrate in bindings. In contrast, I would say stuff like this is sort of semi-blocked on lazy normalization. So rebalancing coherence is probably fairly easy. That's just this, or there's actually two parts to this.
Did you discuss the default stuff? I zoned out a bit.
Default, associated type defaults?
Yeah.
Not yet.
Okay.
Let's talk about them now because they're next on my list to decide how they fit.
Oh, yeah.
Actually, I'm not sure I categorized them correctly. What would you say the work is that's needed is there?
Well, I think you know. I think you know better.
Remind me.
So the open question is when we check well-formedness of defaults. Is it in the trait definition or in the impl? As for work,
Okay.
I don't know how much depends on Jock.
Yeah. So this really is like, this was like the sort of intersection in RFC, right? We didn't try to like invent any new notion of default. We're just trying to apply the existing notion of default to associated types. Is that right?
Sorry, can you repeat that?
I'm saying this RFC, if I'm just remembering now that we had an RFC, it basically tried to apply the existing notion of default to associated types, but not to invent. We had previously thought about, oh, let's make some trees and improve specialization. That's all out of scope. That's a different thing.
Right, except for trait objects. So the thing it does with respect to trait objects is that you can assume the defaults in when you write dyn trait blah.
Okay.
I'm not sure how much work that is.
Yeah, that work seems pretty. I think that doesn't really require chalk to do. I also don't know how much work it is, but I think it's kind of orthogonal from.
Some of it is already implemented in a buggy way, but
Right.
you can maybe reuse that. Some of it.
Mm-hmm. And I realize we don't have a listing here for lazy normalization at all. And I wanted to, that's something I wanted to, but failed to do. Like I started, I would like to get a better, I think lazy normalization is itself too broad of a category. Like there's some very specific, I'm gonna make a heading here for now. There's a very specific, there's like a couple, there's a couple of things we want from it, right? We want some kind of const generics interaction that doesn't work today. And I need to get a good example of this. That's what I was trying to do. I think I found one, but I want to verify it. And then there's sort of improving the bugs around, and then by bugs I mean ICEs and other bad behavior around higher ranked regions and normalization. And just in general reliability. I don't know if there's other classes of bugs. I think those are the two major problems we have today that we want normalization to solve. And I thought it would be nice to dig into, like the last time I did this, I concluded that I really wanted the chalk style solver because of recursive challenges around recursive handling of traits, which chalk handles elegantly. But I would like to reprove that to myself, especially to see if there's like some solutions that will address, like say, const generics without, maybe not in a full way, but enough to unblock. So that might, I think there's some work here of just, I'm going to call like exploratory or like clarifying the problem of just being very clear about what our plan is around lazy norm. Okay. So when it comes to chalk integration, there's, how do I handle this? There are some specific problems, built-in impulse, these sort of things. And there's one, these are very specific to chalk. The handling of region constraints feels like an area that's worth pulling out. And it's not really blocked on anything. It's more like could be done in chalk itself. But I would guess I would put this in the category of somewhere between implementation and specifying. I think I might move it up. Because what we need to do here is sort of decide what our strategy is going to be, make a good case for why it's a good choice. I think it can be done purely, or initially be done in chalk. Okay. So looking at these,
I think we I think you didn't consider type HRTVs and generic closures.
Yeah, you're right. They're not on this list. I would put those under blocked on chalk. Is that true?
Probably. Well, implementation wise, but we still need to do the RFC, and I think we can parallelize some of that work.
Yeah, that seems right. So let's move them up. I guess they're more in the sort of semantic work category, like making RFCs.
Right. But probably more. Well, it's probably the thing that is closest to moving down the list.
Right. So there's like, we can kind of group these into like modest extensions and like bigger ideas, right?
Right.
And I actually think I would put ASREF maybe in between those two, but it feels, I'm going to group it with modest extensions because it's not like a deep.
Right. So you need some attribute syntax to say which things it applies to, and then you need to plug it into the right places somewhere in the compiler.
Right,
So,
but it doesn't like change the expressiveness of the language in any particular way, unlike these other two.
Right. Yeah, you just need to find the places to
right
change.
Of these ones, I don't know. Okay, so I think we should start with 2 or 3 things.
With respect to HRTVs, you can also split that work up into several stages, though I'm not sure if that's a good idea. But it's possible.
Okay. Like, what do you mean by that?
I think we want a syntax for quantifying on closures, like for to gay and then pipes, and then the body of the lambda. And you could do that just for lifetimes to start with, and then you could add constraints on the lifetimes, and then you could introduce types and cosmetics, so you can face it if you want to, but it might get weird in terms of motivating each little bit.
Mm-hmm. Is that so? Some form of, there's currently the first thing you said, which was some syntax for explicit lifetimes, right? That's more generic closures than HRTV, right?
Right.
Okay. I see. Yeah, I don't know that we need to break it into pieces, but I agree that at least that syntax seems separable because it's like actually a problem today. That might be worth splitting out. And I don't know if you saw, but in NLL we encountered some problems here too. If you remember, I could find it somewhere. Felix and I were going over, like in particular when you have partial, some sort of lack of clarity around what exactly type annotations on closures should mean, especially when they're only partially supplied, and when it should be a higher rank thing versus not, and so on. And so one of the, I think I could imagine an RFC just or like a branch of work just digging into that would make sense as a first step.
Right.
But in fact, let's just go ahead and break it out. Syntax, explicit syntax for closure type annotations.
Oops.
And generic closures really means overtypes.
And const generics also, maybe.
Yeah, okay, over non-regions.
Yeah. Also, something like lifetime HRTVs with bounds.
Yeah, I would say let's go ahead and just call this richer universal. Well, it might be separable, I guess. Maybe it's worth separating those things out. Being generic over types is pretty straightforward. It's really bounds that can make it more interesting. But okay, so I feel like we're at it's 1 o'clock. We started a touch late, but that's okay. I'm wondering, this is actually pretty good work, I feel like, that we did here. I'm wondering what the next steps are. And one thing I wanted to do as a start is I feel like this document is huge, and I wanted to break these things out into sub-documents.
I don't want to keep saying we might have missed something, but I think we...
No, please. The list is much more useful if it's complete. So.
So the RFC that Oliver wrote about, const and bounds, that seems, well, it's sort of const VG stuff, but it's also trait stuff. It's the interaction between const and traits.
Okay. Is this the thing that Varkor also was writing about, or is this something else? Like being able to declare that you take a const impl or an impl whose FNs are const FNs. Is that kind of the problem we're trying to tackle? Okay.
Yeah. Basically, we want to use traits and const FNs.
Yeah, that's probably under the bigger ideas category, but it's a little more. I feel like the scope, like until now, bigger ideas meant far in the future. This one doesn't sound far in the future necessarily, but it's still
right.
It's more worked out, so that's good.
It's more of an immediate problem.
Right.
Speak.
Also a little less. It is sort of extending the language in fundamental ways, but somehow less so.
I'm not sure. we're adding an effect system, effect polymorphism for real this time.
Yeah, maybe not. It definitely falls in this category regardless. So I guess the thing would be, I would be curious if each person who wants to might want to pick like 1 or 2 things to sort of nominate. Like I feel like we want to pick in the end some small set of these things to do first and some set to do later. But to start, maybe we can kind of nominate out good next steps. Maybe not live, but maybe live. Like, I feel like I would, for example, I'd probably put lazy norm and GATS, but I don't know. Of like things I really think we should be doing immediately next.
I think we should work on that.
These are not meant to be an exclusive list. Not
unless. I know. I think it unblocks a bunch of different stuff.
Right.
So that's useful. I think personally, after I'm done with the tests and the FCP, I should get back to the HRTVs and generic closures, since I have something there.
So actually, let's ask a slightly different question. Looking at each of these categories, within there, maybe we I bet there's some agreement about what is like most immediately actionable. Like under exploratory semantic work, I feel like HRTBs and closures are pretty immediately actionable here and very high priority. Const impls and bounds too, to a certain extent, but that's also maybe more of a cross collaborative thing.
Yeah.
I feel like, for example, as ref, although I care a lot about it, I would be happy for it to wait for a little while. It's waited this long, I'll wait a little longer. Those should be more like possible.
So I think some of the most important work on HRTVs and generic closures and stuff are the motivation part. It's fairly easy to motivate generic closures, but everything else, like HRTVs without generic closures, it becomes more difficult. So use cases would be good.
So under the specification, yeah, that makes a lot of sense. I'm also like super excited about us emphasizing use cases as like,
but at the same time, I think that, so generic closures is a major thing, but I still think that we should do the less important use case, like the parts of HRTVs that require don't have so many use cases, purely because of like we want language not to be horribly inconsistent.
Yeah, I mean, I would like to specify generic closures. I think also that it's fairly like I'm going to say straightforward, but we're starting to have the vocabulary to talk about that, thanks to Chalk and everything, and it seems like we should be able to do it in a precise-ish kind of way, and then we can phrase generic closures in terms of that vocabulary, and that's all. Like we sort of have confidence that we know what we're talking about. So in terms of specifying work, I highlighted specialization and named existential types. I probably in that order, but I feel like it's really important for us to get a story around specialization. It's been there a long time.
I'm not sure that specifying work is actually, that specialization is actually specifying work. It feels exploratory in the sense that we need to go back and revisit the design itself.
Yeah, that's fair. I think I agree with you about that. I'm going to pull it up to, I think it would fit nonetheless under the modest extensions in the sense, I guess it doesn't matter which category you put it in. But
so I think I see what you mean.
I'm putting it under bigger ideas. I'm disagreeing with myself.
I think it fits in the section on modest extensions if you rename it to things we really need now.
No. I think it fit in the sense that.
So maybe you need bigger ideas that we really need now.
No, I'm putting it under bigger ideas.
All right. Okay.
Yeah, there's an orthogonal. That's the whole point of possible next steps, is to encode the precedence, which is orthogonal. In terms of specifying work, then, I mean, maybe the answer is none. But like, I think implied bound. Oh no, I think it's either. So I think implied bounds is not it, because I feel like it's not that. We have to make progress on Chalk before it's even really that relevant. So we can wait. It's an interesting thing to talk about, and maybe we want to. But I feel like the region constraint stuff is pretty important, and maybe that is exactly the kind of, especially given it kind of intersects and is related to some of the work around universes and stuff. And named existential types, also pretty important. So either of those seem plausible to me. Like the named existential types, how important are they? I don't know how important they are. I was thinking that they intersected async await, which I guess they kind of do.
Well, they're nice on their own. They're very nice on their own.
Yes.
And, well, we've already worked a bunch on them, so we should finish.
Yeah. All right. It's probably worth writing down some of our reasoning. So use cases, well, okay, so they're very useful. In particular, they're useful to address like a key shortcoming of infiltrate, right? Like that they give you a way to have names for these types. Address
and you can also hide things in APIs.
Right.
Like not give out too much.
Right. I'm interested in that. That is a use case. I'm trying to think, like, I want to make sure we're justifying sort of not by how cool they are, but by what key use cases are addressed. Kind of neither of these quite is what I want. I want like, this is really needed to model blah, blah, blah in Fuchsia or something, but that's okay. I feel like there is probably answers like that. I just don't have them on the tip of my tongue.
Well, I would add that we have already done, what you said. Yeah, that.
Right.
It's just us left, I think.
Yeah, it's just us. At some point, the others have to go in. That's fine. I got to run too in a second, but
I didn't notice.
But we're so close to like reaching a stopping point. So handling region constraints, I think a challenge for Nico is justify why I feel this is important. I think it's important, but I want to think more about it. And maybe it's more of as part of chalk work. I don't know. So on the implementation side, or this implementation work category, I think unblocking lazy norm, pretty clearly important. This is, or let's see, how was I doing this? I was writing a separate list of, possible next steps. Bold. Okay. So clarifying the lazy norm problem. I think generic associated types. These are the two that jump out at me as like unblocking stuff. And existential lifetimes in infiltrate. This is important for async await ergonomics. I mean, and also anyone using and infiltrate ergonomics, but particularly async await.
This is the issue that this is the pull requests that Taylor made, and then who was it? Found a silence hole.
Matthew Jasper, I think, highlighted a silence hole. Yeah. I mean, right, exactly. That's the one. I think there's probably also some. I'm kind of using this as a shorthand, and I probably should dig into that a little more. There are some lifetime-related problems around async await, and I suspect there's like one or two or three, and I'm using this to some extent as a shorthand for all of them, which is sloppy because there might be two different pieces of work that need to be done. I'm not exactly sure. I'll figure that out.
But are they the sort of problems that we need to figure out before we ship? Like, we don't want to find out after we ship that, oops.
There's some debate about that. I don't think they're the sort of problems. It's not that we're accepting code that we don't know if we should accept. It's more that we are not accepting code that is very common.
Right.
But we want to do it the right way. I'm a little
But are they like unlivable paper cuts?
It depends on who you ask. Yeah. I think they're borderline non-livable. Yes. So example would be like you can't have an async FN with two lifetimes in its signature.
Wow.
It's pretty.
Yeah.
It's pretty extreme.
Oh yeah.
And that. So yeah. Anyway, I would put the rest of these things as lower priority. I think they might be worth digging, especially the infiltrating bindings. Alex, Reg, and I had talked about spending some time making a roadmap, but not necessarily doing it, just because we've kind of already had the thoughts. It would be good to collect them in one place so that when we come back to it, we know what we're saying.
So many of these things can be done in parallel, I think. And if we can try to sort of write up mentoring instructions or describe.
Right, this is the question, yeah. I think they can, but sorry, I didn't mean to cut you off, but I totally agree. I'm just a little wary of like, we have to find the right set of mentors because a lot of them are things that I would have mentored and I don't feel capable of like mentally juggling all of these things. But to the extent that like other people are doing that, I'm all for it.
Yeah.
So that's the question: is what amount of bandwidth can we find there of that kind? All right, cool. Well, let me go because I got to eat lunch sometime. And thank you for hopping on the call. It was super helpful. And we'll talk. I'm going to try to shop these around and also go into the ones that are highlighted as possible next steps, especially on the implementation side. Try to drill a little more into what that means. But
cool.
Talk to you later.
Did we discuss multi-trait objects, by the way?
Oh no, we didn't. We should put that on the list. I think that falls under some sort of probably modest extension exploratory work category, but
that seems important.
Okay.
Like something that people.
I think what we didn't do yet is we identified like possible next steps, but we didn't identify what happened. The short list of like after that, what do we do? And I think I tend to agree that multi-trait objects and trait object upcasting are like kind of on that list for me because they're just annoying limitations with the language today, like long-standing annoying limitations.
Well, there's so much on this list that is that, but yeah.
Well, yeah,
but yeah, I agree. At least
like stuff you think should work but doesn't. Doesn't feel like a feature so much as a bug fix. But
oh yeah. But if you're very used to Haskell, then everything feels like a bug.
Yes, that's fair.
But yeah, that seems more like try different layouts and see what has the best performance or something.
Yeah, it's a little different in character than the other forms of design here. It's a little more lower level and so on. But yeah. I think there's also some questions. That's actually, to me, the easy part. Yeah, we got to find some V tables or whatever. But like I'm not sure, but I feel confident if we start digging in. I mean, and for that matter, just putting trait objects into Chalk is already a sort of bit of work that needs to be done, which is related to this, and I think fairly high priority. It's as among the set of things to do in Chalk, it is fairly high priority. So, to the extent that that's a goal, that's another part of this that didn't. I want to revisit is like how to think about the Chalk work on its own. I kind of want to have some trajectories where we're like, reaching the point with the right pieces in place when we need them to be in place. Yeah, and maybe handling trait objects in Chalk. Like if I were doing that work, I would want to be thinking ahead to multi-trait objects already. Right? So maybe that's handling the complex semantic questions. Then it's just the V tables. Yeah.
No, that makes sense. As for the V table, we could not specify the layout and just keep that stabilized but not specified.
Yeah, we may want to do that. Leave it as an implement. Regardless, we have to come up with a plan. But yeah.
Yeah. Of course, people, even if we do unspecify it, people will still assume it because transmute is really annoying.
Right. All right. Talk to you later.
Talk to you later.